Alright, so today we'll begin our study of electrochemistry. It's basically a subject which deals with the interplay between electricity and chemical reactions, how electricity can be produced from chemical reactions, and how we can use electricity to actually cause chemical reactions. So, Tushar, will you please take us through this subject and what we will be studying in this particular topic?
इलेक्ट्रोकेमिस्ट्री हमें पहले इलेक्ट्रोकेमिस्ट्री पढ़ने से पहले पता होना चाहिए कि इलेक्ट्रोकेमिस्ट्री है क्या. तो इलेक्ट्रोकेमिस्ट्री में हम स्पॉन्टेनियस केमिकल रिएक्शन से इलेक्ट्रिसिटी प्रोड्यूस करते हैं और इलेक्ट्रिसिटी को नॉन स्पॉन्टेनियस केमिकल रिएक्शंस में यूज़ करते हैं. अब इलेक्ट्रोकेमिकल सेल्स दो टाइप के होते हैं, इलेक्ट्रोलिटिक एंड गैल्वेनिक. अब हमें इन दोनों में डिफरेंस पता होना चाहिए.
Yeah, this is quite important to know the difference between an electrolytic cell and a galvanic cell. So please take us through it.
इलेक्ट्रोलिटिक सेल में हम इलेक्ट्रिकल एनर्जी से केमिकल एनर्जी में कन्वर्ट करते हैं, जबकि गैल्वेनिक में हम केमिकल को इलेक्ट्रिकल में कन्वर्ट करते हैं. इलेक्ट्रोलिटिक सेल में एनोड पॉजिटिव इलेक्ट्रोड होता है और कैथोड नेगेटिव इलेक्ट्रोड होता है, वेराज गैल्वेनिक में उल्टा होता है. इलेक्ट्रोलिटिक में आयंस दोनों इलेक्ट्रोड्स पे डिस्चार्ज होते हैं, जबकि गैल्वेनिक में सिर्फ कैथोड पे डिस्चार्ज होते हैं. इलेक्ट्रोलिटिक सेल में हम दोनों इलेक्ट्रोड्स को सेम कंपार्टमेंट में रख सकते हैं, पर ये गैल्वेनिक में पॉसिबल नहीं है. गैल्वेनिक में दोनों इलेक्ट्रोड्स को हमें डिफरेंट कंपार्टमेंट में ही रखना पड़ता है.
Alright, so these are some of the basic differences. Just keep them in mind. Alright.
स्पेसिफिक कंडक्टेंस और कंडक्टिविटी. कंडक्टेंस किसी भी इलेक्ट्रोलाइट सॉल्यूशन का ये मेजर होता है वो कितनी इलेक्ट्रिसिटी कंडक्ट कर सकता है.
अच्छा, and it's basically a property of the substance itself, of that solution itself. Specific conductance.
इसका कैलकुलेटिंग फार्मूला होता है कप्पा इज इक्वल्स टू L by A into 1 by R.
Alright, so can you explain to us what L, A, R, these quantities are?
R is resistance here, whereas L and A are length and area of the electrode respectively.
Alright, so as you can see, the specific conductance is directly proportional to the length and inversely proportional to the area and the resistance. Alright, and what are the units we use for that?
Units for these for kappa is ohm inverse cm to the power minus 1.
Alright.
मोलर कंडक्टेंस. मोलर कंडक्टेंस को हम जितने भी आयंस उस सॉल्यूशन में उन सबका एक साथ
Alright, it's basically the conductance of all the ions, right?
Yeah.
Just to take us through the definition.
Molar conductance is defined as the conductance of all the ions produced by ionization of 1 gram mole of electrolyte किसी given quantity of solution में. अब इसको हम म्यू से या लैम्डा से डिनोट कर सकते हैं, और इसके लिए हम जो कैलकुलेटिंग फार्मूला यूज़ करते हैं वो होता है K इक्वल्स टू 1000 by C. यहाँ पे K कप्पा वही है स्पेसिफिक कंडक्टेंस एंड C इज कंसंट्रेशन.
Okay, so lambda is equal to K into 1000 by C. Alright. So this is what we know as molar conductance, right? Alright, so we'll move on to the next part. Okay, next we'll study a few laws and important equations dealing with electrochemistry, which pretty much define the topic as a whole and are pretty important to learn and remember. So Tushar, will you please take us through these laws?
Okay, now we'll be studying what are Faraday's law. So Faraday's first law. The law states that the mass of the substance deposited or liberated at any electrode is directly proportional to amount of charge passed, that is W is equals to ZQ. यहाँ पे W डायरेक्टली प्रोपोर्शनल है चार्ज के. यहाँ पे W मास है सब्सटेंस का और Q वो चार्ज है जो इलेक्ट्रोड से पास हुआ है. Now
so W is the mass of the deposited substance and Q is the amount of charge. Alright, and Z is a constant of proportionality. Alright, so I guess you must have understood that. So yeah.
Faraday's second law. ये सेकेंड लॉ कहता है कि जो भी मास डिपॉजिट हो या लिबरेट हो किसी इलेक्ट्रोड से, अगर दो अलग अलग इलेक्ट्रोड से वो जो भी मास डिपॉजिट या लिबरेट हो किसी भी इलेक्ट्रोड पे, तो जब अगर हम कुछ अमाउंट ऑफ चार्ज पास करेंगे, उसे फिक्स कर देंगे हम चार्ज की क्वांटिटी, तो वो उसके केमिकल इक्विवेलेंट की डायरेक्टली प्रोपोर्शनल होगा. दैट इज W वुड बी डायरेक्टली प्रोपोर्शनल टू E, और हम इसको लिख सकते हैं W इक्वल्स टू KE.
Okay. So, what is E exactly? Can you explain to us? What is chemical equivalent weight? And
केमिकल इक्विवेलेंट वेट हम डिफाइन करते हैं किसी भी सब्सटेंस के मोलर मास से अगर हम उसके n फैक्टर को डिवाइड कर दें तो वो केमिकल इक्विवेलेंट आ जाता है.
all right. Yeah. So basically, we get W is equal to K into E, as W is directly proportional to the chemical equivalent weight. All right. So we move on to the next part.
अब मैं आपको एक खास फॉर्मूला बताने वाला हूँ जो दोनों फैराडेज के लॉज को मर्ज कर देगा. अगर सिर्फ ये फॉर्मूला आता है तो दोनों फैराडेज के लॉज इसमें कवर हो जाएंगे और एप्लीकेशन भी इन्हीं लॉज से, इसी फॉर्मूले से हो जाएगा.
Right. So this is a way to compile all the information given by the two laws into one equation. Right.
So this formula is W by M equals to Q by NF, where W is the molar mass, M is the molar mass, W is the mass of the substance, Q is the charge, N is the number of electrons exchanged, and F is the Faraday's constant.
Okay. So W is the mass of the deposited substance, M is the molar mass, and Q is charge, N is number of electrons, and F is Faraday's constant. You would know.
इलेक्ट्रोड पोटेंशियल. अब इलेक्ट्रोड पोटेंशियल किसी भी सेल की E नॉट एनोड एंड E नॉट कैथोड होती है. यहाँ पे E नॉट इज द इलेक्ट्रोड पोटेंशियल एट एनोड एंड E नॉट कैथोड इज इलेक्ट्रोड पोटेंशियल एट कैथोड.
So basically, electrode potential of the cell is the sum of the potentials at the anode and the cathode, respectively. All right.
अब कोलराउज लॉ, ये लॉ काफ़ी इंपॉर्टेंट है बिकॉज ये काफ़ी जगह बेसिक की तरह यूज़ होगा. ऑलमोस्ट काफ़ी क्वेश्चन में होने वाला है ये यूज़, तो इसको ध्यान से देखें. ये कहता है कि कंडक्टिविटी ऑफ आयंस इज कांस्टेंट एट इनफाइनाइट डाइल्यूशन एंड इट डज नॉट डिपेंड ऑन को आयंस. बेसिकली इनफाइनाइट डाइल्यूशन पे किसी भी आयन की कंडक्टिविटी दूसरे को आयन पे डिपेंड नहीं करती. वो अपना पूरा अलग से देगी और दूसरा जो को आयन होगा वो अपनी पूरी तरह से कंडक्टिविटी देगा. वो इनफाइनाइट डाइल्यूशन पे इंडिपेंडेंट होती है एक दूसरे से और अपना इंडिविजुअल कंट्रीब्यूशन देती है.
All right. So at infinite dilution, the conductivity doesn't depend on the other ions in the solution. It has its own independent value. All right.
अब हम नर्स्ट इक्वेशन देखते हैं. ये सबसे इंपॉर्टेंट फॉर्मूला है इस चैप्टर का.
Before the Nernst equation, can you just please take us through the previous equation that is displayed there under Kohlrausch's law?
So this is conductivity of the whole solution, which is conductivity of cation plus conductivity of anion. This M and N are the number of moles which are in a substance. Like
All right.
if the compound is A2B3, so it would be 2A and plus 3B.
All right. Number of moles of cations and number of moles of anions. Yeah. Multiplied by the conductivities gives the total conductivity. All right. So now we move on to the Nernst equation.
This is the most important equation of this chapter. So E cell equals to E naught minus 0.0591 by N log product concentration by reactant concentration on the base 10. अब
Alright.
यहाँ पे E naught is the standard electrode potential, N is the N factor, this is the product concentration, and this is the concentration of reactant.
All right. All right. So in this next part, we'll study some important concepts in electrochemistry, one of which is Gibbs free energy, a very important quantity in thermodynamics. And then we'll move on to studying batteries and their various types. So Tushar, please take us through this particular part of the topic.
So now we'll studying Gibbs free energy. Gibbs free energy is a thermodynamic quantity and it helps in predicting the spontaneity of a process. By spontaneity we mean would the reaction be like the reaction would be feasible. So its calculating formula is minus NFE. Now I have provided you with a chart here, and in this chart, there are almost all the formulas required in this chapter. So it would be a collection for you guys, and it would be very easy to revise from this chart.
Yeah, so you can look through this chart, and it's a very good pictorial representation, and it'll help you remember the formula as well. By spontaneous reactions, like he said, it means will it happen, in a natural process or not, without any external stimulus or external energy. You can see this chart, and he'll explain it to you a little bit.
Okay. अब हम ये वाला सबसे पहला फॉर्मूला देखते हैं, लाइक डेल्टा जी इज इक्वल्स टू डेल्टा एच माइनस टी डेल्टा एस. ये वाला फॉर्मूला आपको थर्मोडायनेमिक्स से याद होना चाहिए. ये वहाँ से फॉर्मूला यहाँ पे डाला गया है. नाउ डेल्टा जी नॉट इज इक्वल्स टू माइनस एन एफ ई नॉट. दिस इज द फॉर्मूला आई जस्ट टोल्ड यू. नाउ द रिलेशन बिटवीन डेल्टा जी एंड के, that is equilibrium constant, is delta G naught is equals to minus 2.30 RT log K on the base 10.
Alright, what is K exactly here?
K is equilibrium constant.
Okay, the equilibrium constant of the reaction. Yeah, alright.
Now, the relation between E naught and K is E naught equals to 2.303 RT log K on the base 10 by NF.
Alright. Yeah, so you can just look through this figure, and it has all the relevant equations, and it's nicely presented, so it's easy to remember. Now we move on to studying batteries. Okay.
Batteries. As you all know, batteries are one of the most important things in our life. So now we'll study battery. Battery is basically a source of electricity, and it's a galvanic cell.
Alright.
As we all know, it converts chemical energy or spontaneous redox reaction into electrical energy.
Okay.
Now we'll study the types of batteries.
Okay. Before that, can you tell us the difference between a cell and a battery?
A battery is a group of cells, whereas a cell is a single unit.
Alright. So battery is a group of cells connected in series. Alright. We'll move on to studying the types of batteries.
Now mainly there are two types of batteries, primary and secondary. Now we'll see what is the difference, what these two types of batteries are. So primary batteries or voltaic cells, that is dry cells. ये वही cells हैं जो हम remotes में and pencil cells की तरह use करते हैं. Now in this type of cell, once the chemical reactions have been consumed, further the reaction is not possible. So if your battery, if it is used once, it becomes dead, and hence it cannot be reused.
Okay, so basically it cannot be recharged. It's not a rechargeable battery. All right.
Yeah, like for this type of battery, the reversible reaction is not possible. Like the reverse reaction is not possible. The current hence flow in one direction only.
All right.
Most common example for this type of cell is the dry cell, as I told you in the beginning,
which we use normally in torches and other equipment. All right. So we'll move on to the next part. So in this section, we'll be studying the dry cell, which, as we had mentioned earlier, is the most common example of a primary battery. So Tushar, please take us through what a dry cell is and what its properties are and everything. It's a pretty important concept.
Dry cell. So we have to study what dry cell is exactly. The container of the dry cell is made of zinc, which is used as one of the electrodes. The other electrode uses carbon in the cell. The zinc container is lined with a porous paper, and this is very important for the cell.
Alright.
A moist mixture of ammonium chloride, manganese dioxide and zinc chloride are filled in between the spacing. It is between the zinc container and the carbon rod that both serves as an electrode. So this is basically the electrolyte. Alright.
So can you tell us why the porous property of the paper is important, or the porous inert filler?
Porous lining of this is very important because without this the cell won't work. There needs to be some porous, like so the solution electrolytes to pass.
Yeah. So for the proper passage of the electrolytes. Yeah, correct.
Now I have provided you with the primary cell reactions here. Here zinc is getting oxidized at anode to Zn2+, whereas at cathode ammonia is getting reduced to ammonia, ammonium is getting reduced to ammonia, and this is the net cell reaction.
Yeah, and you can check out the diagram as well. It's pretty well represented, and you can get an idea of the basic structure of the dry cell, and the equations are pretty straightforward as well. It's been summarized in this table, so you can check it out, and we'll move on to the next section. Okay, so now we'll move on to studying the other kind of batteries, that is secondary batteries or voltaic cells. Okay, so Tushar, please take us through this kind of battery.
Secondary batteries. These are the batteries in which the original reactants are regenerated by passing current from external source. That is, these cells can be recharged, and this is the most important thing about these cells. Lead storage battery are one of the best examples for this type of cell. So now we'll see what are lead storage batteries exactly. Now lead storage batteries consist of group of lead plates which are made up of spongy lead, and these are alternating with a group of lead plates bearing this lead oxide, that is PbO2. These plates are immersed in concentration of H2SO4, which is 30% of H2SO4.
Alright, so it's spongy lead plates alternated with lead plates with lead dioxide. Alright, and immersed in a solution of H2SO4, 30% H2SO4. Alright.
Now this is the diagram for the lead storage battery, and these are the reactions for lead storage battery. Here we can see that at anode lead is getting oxidized to Pb plus 2, and at cathode PbO2 is getting reduced to Pb2 plus, and this is the net reaction for this type of batteries.
Alright, so you can study the diagram and get an idea. It's a pretty simple diagram. You can get an idea of what the cell is made up of, the battery is made up of, and the reactions are also pretty simple. Just go through them, and the overall reaction is given at the end, and it's apart from that, it's pretty easy. Okay, now we move on to studying fuel cells, which are really important both as a theoretical concept and for practical applications in our daily life. So Tushar, please take us through this the fuel cell and the various kinds of fuel cells.
Now we'll study fuel cells. Fuel cells are the most energy efficient and eco-friendly cells. Well, these are just a type of cell in which we convert chemical energy to electrical energy, as the name cell suggests, in the fuel cell. But the main disadvantage of this type of cell is that this can only be used for a short period of time.
Alright.
And this is due to the quantity of oxidizing agent and reducing agent is it's quite limited for these cells.
So it can only be used for a limited amount of time. Alright, fine. So we'll go on to a kind of fuel cell called the hydrogen oxygen fuel cell.
Now we'll study a type of fuel cell, that is hydrogen oxygen fuel cell. Well, the cell consists of 3 compartments which are separated by porous electrode. Hydrogen gas is introduced in one of the compartments and oxygen gas is fed into another compartment.
Alright.
Now I have provided you all with the reactions for a fuel cell. This is the hydrogen oxygen fuel cell. At anode this H2 is getting oxidized to H2O, whereas at cathode O2 is being reduced to 4OH minus, and this is the net cell reaction, and as you can see the byproduct is water only.
Alright, so the only byproduct is water, and the reactions that the various electrodes are given, and the overall cell reaction is also a very familiar one and pretty simple to remember. So we'll move on to the questions now. Alright, so now we move on to solving a few questions. Here in this question we have a given reaction and we have to find out whether that is feasible or not using the Gibbs free energy method. Tushar, will you please take us through the question?
Well, the question talks about the oxidation of sulfate by oxygen. So we'll proceed this question by writing the half reactions first. So the half reactions for the reaction are 2 SO4 2 minus gives H2O8 2 negative plus 2 electrons, whereas the second half reaction for this is O2 plus 4H plus 4 electrons gives 2H2O. This is same as the given one. Now
the half reactions are also given in the table. You can check it out.
Now we need to balance, we need to add these reactions, but as we see, the electrons are not balanced. Here are 2 electrons and here are 4 electrons. So what we'll do is, we'll multiply the above equation by a factor of 2.
To get the equal number of electrons.
Well, we can even divide the lower equation by half, but we'll get integral numbers by multiplying by 2, so the question would seem a bit simpler. Now we'll write the whole reaction. It would be 4 sulfate plus oxygen plus 4H plus gives 2 H2O8 2 negative plus 2 H2O. So this is our net reaction. Now we need to check the feasibility for the reaction, and for this we need to check the value of delta G.
Alright, the Gibbs free energy.
So delta G here is delta G ऑक्सीडेशन, ये वो है जो ऑक्सीडेशन से डेल्टा जी है, whereas plus delta G reduction,
which would give us the total delta G, right?
Now as we can see, the above two reaction, one of them is oxidation and the other is reduction. This is the oxidation one and this is the reduction one, as electrons being added to it. So as I told you in the beginning that delta J is minus NFE. So here it would be minus NF E oxidation, and here it would be minus NF E reduction. Now as N is 4 here clearly here, and here we can see it is 2 into 2. So N is 4, that is N factor, and we can take that common. So we'll take out minus N, that is 4, and F common. Now we need to add E oxidation plus E reduction. So E oxidation and E reduction values are directly given in the question. So we'll write them directly, which is minus 2.01 plus 1.23. Now this gives us plus 4 F 0.78. We can see that delta G is positive, and hence the reaction is not possible.
For spontaneity, delta G has to be negative. And another thing we have to point out is, just go up to the top of the question. So as you can see, this reaction, the second reaction given in the table, is the opposite of the reaction that is actually happening in the electrode. So when you take the value of E naught, you have to reverse the sign, because the reaction is getting reversed in this cathode, in the electrodes here. Alright, so be careful with that, the changing of the signs and everything. So here we get a positive value for delta G, and therefore we conclude that the reaction is not spontaneous, and so this reaction will not occur spontaneously. So we come to the end of this question. Alright, so the next question deals with the concepts of specific conductance, molar conductance, kappa, cell constant, and all these important concepts that we had studied earlier in the theory part. So Tushar, please take us through this question.
So in this question, we are given the concentration of KCl, its specific conductivity, and its resistance.
Alright.
This is at 298 Kelvin. And the other thing is for the next part. So first we'll solve the A part.
All right.
Now, as I told you before, kappa is equals to 1 by R L by A. This was told in the theory.
Yeah.
So for the first part we need to find the cell constant, that is L by A.
All right. So L by A is the cell constant for a particular cell. Yeah. And you can go back to the theory and revise this part if you've forgotten.
So L by A is equals to kappa into R. Now kappa and R are directly given in the question. So we'll directly multiply 0.2768 into 82.4. So this gives us 22.81 meter inverse.
Yeah.
For the next part,
Okay, now we have to find the conductivity of potassium sulfate solution. Yeah.
So we know that the cell constant does not change, it remains constant. So we'll use here kappa equals to 1 by R L by A. But the resistance for the other part is given, and this is 326 ohm.
Yeah.
So we'll write kappa equals to 1 by R L by A. We have calculated L by A in the previous part, and the value of R is given. So if we'll directly put the values, it is 1 by 326 into 22.81.
Yeah.
So this gives us 0.07. The units here are very important. Here it is ohm inverse, meter inverse.
Correct. Yeah. So this is again pretty straightforward. We calculated the cell constant from the previous example. Just put in the value of the resistance and you get the specific conductance.
For the third part, we need to calculate the molar conductivity. We know that molar conductivity is represented by this capital lambda, and it is equals to kappa into 1000 by the concentration, which is M here. M here is molarity. The concentration can be anything. That's a general word. So here kappa is 0.07 as we just found.
Yeah.
Into 1000 by M.
Yeah.
Well, M is given in the question and it's given here. These things, the value should be initially underlined as these are very much helpful while solving the questions. So it is 0.0025.
So in this example, this concentration is represented by molarity, but it can be represented by other forms also.
So it's 28,000 ohm inverse centimeter square mole inverse.
Yeah. All right. So the units are pretty important, so just keep them in mind. All right. So we come to the end of this question. We'll move on to the next question.